Let's talk briefly about this idea of duration and interest rate risk. The duration of a bond is the measure of its interest rate risk. And in English, duration and maturity are synonyms. And this word was chosen for this reason, that it's a lot like the maturity, and we'll see that this is pretty much related to this. But here I have the price of a bond, and that's a function of the coupons, the discount rate, the number of payments that I receive, and the maturity value. So which of these could change by tomorrow? If I go to bed tonight and I wake up tomorrow morning, what could cause the price of my bond to change? And if I look at all these variables, these inputs, I can see that the only thing that can change by tomorrow is going to be Y, the yield to maturity. Well, it's half of the yield to maturity. Now, why might yield to maturity change? Well, it could be time value of money or credit. It's not likely that the liquidity is going to change. The market's not going to change. And so, if I calculate the change in price for a change in yield, and then I divide that by the initial price to get a percent change, then I'm going to get this measure of duration. And what this is effectively the first derivative of the price with respect to the yield. And I can see that since this is in the denominator, it's going to be a negative number. And so again, by custom, we just take the negative to report a positive number. And so the duration is the first derivative of price with respect to yield divided by the initial price to give me a percent change number. And what this is telling me is how much interest rate risk is there in this bond? How much different might the price be if the interest rate, the yield to maturity, changes? And again, the yield to maturity can change because of pure time value of money or credit. And so I calculate the duration as a measure of interest rate risk. And we're going to see that there's a number of factors that affect this, but the most important is going to be maturity. The longer the term to maturity, then the further out my cash flows go, and the further out my largest payment, which is my maturity value, and so this is a larger value, and so the greater the change in the greater the change in price for a given change in Y as a function of maturity. And so if I have a 10% discount rate that goes to an 11% discount rate, and I'm going to get the payment next year, that's not as big a deal as a 10% discount rate that goes to an 11% discount rate for a payment that comes in, say, 15 years, because then I'm going to have taken this to the 15th power as opposed to the first power. So let's go to a couple of graphs and we can see what this looks like. So here I have a table, and what I have is the term to maturity, and all I'm going to do is I'm going to calculate what the price of this bond would be at different yields to maturity. And I'll use the PV function because I have an integer number of periods. So I'll do equals negative PV, open parenthesis, and then it's going to be the rate, and that's going to be the discount rate, which is the yield to maturity, divided by 2, the number of periods, which is 10 times 2, the payment, and that's going to be the coupon rate, divided by 2 times the face value, and then again the face value, click that, and I see I got $193, and that's because it's a 10% coupon rate bond. Yield to maturity is tiny, and the only way to earn 0.5% on a bond that pays 10 is to way overpay. And I'm just going to click this, and it's going to populate down. And notice that I get to exactly $100, which is equal to the face value when the yield to maturity and the coupon rate are equal. And now I'm just going to graph this. I'm going to graph yield to maturity, and I'm going to do this relative to price. And I'm going to highlight both of those columns. I'm going to go to insert recommended chart, and you can see I have this chart here. I'm just going to cancel this, and I'm going to go to the next tab where I already have this done and formatted. And so let's take a look at this. I have price of the bond on this axis as a function of the yield to maturity. And note this is a downward sloping line. As the yield to maturity gets bigger, the price gets smaller. And that makes sense because yield to maturity is in the denominator of my function. But also note that it's decreasing at a decreasing rate. It's not a straight line, it's curved. And so if I look at the steepness of this line, it's steeper here relative to here. And so what that means is that if I have an increase in interest rates from say 4% to 5%, if I have an increase in interest rates from 4% to 5%, you can see that I'm going to have a price drop, and I'm just going to highlight those. I'm going to have a price drop, the price drop from a 4% interest rate to a 5% interest rate. I'm going to lose $10. But if I'm way over here and I have an increase from, say, 14% to 15%, 14% to 15%, my price drop is only $4.30. Let me just highlight those as well. And so the point is that here I have a 1% increase in rates and a $10 drop in price. Here I have a 1% increase in rates, but only a $4 drop in price. And so the line is significantly steeper here than it is here. And so the steepness of the line is the change in price for a change in yield. It is measuring interest rate risk, and this is effectively the duration of the bond. And so that as I have a higher interest rate, the interest rate risk or duration is smaller. On the next tab, I have done both a 5-year bond and a 10-year bond, and I have both of these graphed. And now you can see that the blue line is everywhere steeper than the orange line. And so to go back to those same values, to go from a 4% to a 5%, you can see that the change in price, nope, screwed that up, that should be from there. So that is the price change for a 1% change in rates from 4% to 5%. But note, and that's going to be essentially the decrease in the blue line. Here's going to be the decrease in the orange line. Let me just move that over a bit. And you can see that for that same 4% to 5% increase in rates, I only have a $5 change. And so I can see that the orange line is flatter than the blue line. And just to do the same thing down here between 15% and 14%, that was the drop that we saw before. And now for this bond, I can see that it's correspondingly smaller as well, only 311. And so everywhere the orange line is flatter than the blue line. And what that means is, because the maturity is lower for the 5-year relative to the 10-year, it has less interest rate risk. It therefore has a smaller duration. If I were to calculate the first derivative of the price with respect to the yield and then divide it by the original price to get an approximate percent change, I would see that the 5-year bond has a smaller duration and therefore less interest rate risk. And the 10-year bond has a higher duration and therefore more interest rate risk, and I can see that depicted by the steeper slope of the blue line relative to the orange line. Also, just note that both bonds are priced at par when the yield to maturity is equal to the coupon rate, and that's true for both bonds.